Lesson 4, topic triangle congruence by angle, side, angle, and angle, angle, side. Learning target, I can prove triangles are congruent using side lengths and angle measures. So our two, new ones, we have a postulate and a theorem. So the first one is angle, side, angle. So similar to side, angle, side, where you have an included piece, but this time the included piece is your side. So we have if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. And then we have angle, angle, side congruence theorem. So if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the two triangles are congruent. Also, it does have to be a corresponding non-included side. So as you can see in the diagram, the side is the same as the one that corresponds to the other side. So BC corresponds to EF. It couldn't be that BC was congruent to DE. That wouldn't work because that's not corresponding because of the angles that match. So let's practice. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So let's look. Here we have side and an angle, angle and a side. And also we have vertical angles. If you look, you got crisscross vertical angles. So we have angle, angle, side, angle, angle, side. It's a corresponding side. So yes, by angle, angle, side. On our part B, if we look, we have all the angles are congruent, but we don't have any information about the sides. So we don't have enough information to say that these triangles are congruent. And then let's look at number C. Yep. Okay, letter C. So we have an angle congruent to this angle. We have a second angle. And then they share a side. So we have angle, side, angle. That side is included in between the two angles. So yes, by angle, side, angle. All right. All right, let's practice. We have in the diagram at the right, what postulate or theorem can you use to prove that triangle RST is congruent to triangle BUT? Explain. Well, right now we know we have a side that is congruent to another side, an angle that's congruent to another angle. We don't have any other information about the sides, but we can get one more angle because we do have right here vertical angles. So then if we look, we have angle, angle, side, angle, angle, side. So we can use angle, angle, side because we have angle RTS is congruent to angle UTV. We have angle S is congruent to angle U, and we have RS is congruent to UV. So we can say triangle RST is congruent to triangle VUT by angle, angle, side. And lastly, let's do a proof. Given angle A is congruent to angle D, angle C is congruent to angle F, and BC is congruent to angle, or BC is congruent to EF. Prove ABC is congruent to angle DEF. Well, I mean, this is very, very cut and dry proof. We've got 3 givens. And if we look, we have angle, angle, side. So angle, angle, side, angle, angle, side. So our triangles are congruent by angle, angle, side, congruence theorem. And that's all the notes I have for you. Go ahead and move right on into your practice.